Thank you. Good morning. Today I shall be speaking about a performance toolkit for shift teams created by combining Pi system data with our own Shiftconnector software and a little bit of Power BI. Now, at this stage, some of you may be thinking, do we really need another system? We have all our readings from Pi, we know our flow rates, we know our temperatures, we know our batch cycle times, etc. And we appreciate this, we really do. However, often there is one vital piece of equipment or information missing, and that is context. Or to be more precise, human context. Why are we having slow batch cycle times? Why are we producing so much scrap, etc.? And within our Shiftconnector software, we have developed a managed process to enable you to capture this information. And today we shall be looking at a best case example from our client Stora Enso, based in Langenbrugge in Belgium, to show you how they did that. But first, I'd like to introduce you to Eschbach. We are a German software company founded in 2005. We have offices in South Germany, close to Basel on the Swiss border. We have offices in the States, in Boston. And we installed our first Shiftconnector solution about 14 years ago to a former Roche vitamin plant, now part of DSM. And in the intervening 14 years, we've developed our product suite and our customer base. And today we have installations in 21 countries around the world. We are also an OSI soft independent software vendor, and we have many compelling reasons for integrating Pi data with our Shiftconnector software. However, the most compelling today is performance tracking for asset utilization and OEE. We are focused on the process industries, chemical, pharma, today's example, pulp and paper manufacture. And our software is suitable for all process types, continuous, batch, multi-purpose. And we have many multi-site global implementations of our solution. Over the years, we have realized that when it comes down to effective results, regardless of how good your technology is, often the vital ingredient is effective communication. And this is effective communication between people. If we look at a modern plant structure, we obviously have our process data, we have our systems, and then we have our people. Teams, groups of people, essential to the continuation of quality production within our facilities. And there is also the corporate interest. Are we maximizing our return, our asset utilization, etc.? In the situation where Pi throws up an error on the system, this starts a chain of human reaction, or can start a chain of human reaction within your organization. And very quickly, within the course of a day, this can grow exponentially. And it's a very important and necessary process to ensure quality of production. If we focus on the shift in a little bit more detail, this presents an additional challenge because production needs to continue while shifts change. And in order to handle this, most organizations have a 15-minute shift handover meeting. And this is 15 minutes to hand over the shift, to review all the events that have gone on in the previous shift and events which have carried over from earlier shifts. Look at all the outstanding tasks. Look at all the tasks which may have been completed but need to be monitored. Look at any health and safety issues, etc. 15 minutes to ensure continuation of production. If you consider for a moment the cost of downtime within your own facilities, what are we talking about? Are we talking about tens of thousands, hundreds of thousands, millions of euros per hour? If we consider it in these terms, these 15 minutes are probably the most valuable 15 minutes of each of your shift sessions. If we look in a little bit more detail at a typical 3-shift system, and I appreciate there are 4 or 5 shifts or fewer shifts, but this is very typical within the process industry. If we look at a typical 3-shift system, we have our night shift, our morning shift, our evening shift, and operations come in sometime after the evening shift goes home. And what this means in reality is if operations have any questions about what's happened in the evening shift, there is no one physically present to answer these questions. And to address this, we maintain logs. So the shift supervisor maintains a series of logs to ensure that people know what's going on. And even in today's modern process environment, there are many organizations still using paper logs, still using Excel spreadsheets, still using a combination of homespun databases, as well as the maintenance systems and email, don't forget. And at the end of the shift, there's 15 minutes to go through all of these systems and communicate all the relevant information to the incoming shift supervisor so they can maintain production. And let's not forget operations. If they have any questions, they are dependent upon the effectiveness of these shift handover meetings to get answers to their questions. And then the incoming shift supervisor maintains the logs, and then another meeting, and then maintain the logs again, and another meeting. And this continues every day, 7 days a week, 365 days a year, year in, year out. Now, I appreciate you probably all appreciate the downtime cost in your facilities. But did you know it is estimated in a production environment that 50% of all failures typically occur within 30 minutes of one of these shift handover meetings? And we believe this is largely due to the variety and complexity of the systems which are in use. We believe what's required here is a single point of truth, a single system that enables all the people within your organization that need access to this information to access this information, all the systems that need to be integrated with and communicated with to be integrated with and communicated with. And that is exactly what we have built. We have built an award-winning platform that leverages collaboration and communication within your production facilities, that enables you to handle effective shift handovers to avoid these downtimes, and a system that enables you to really leverage your OEE and process analysis, etc., by leveraging the intelligence from the operators, the knowledge of the operators within your workforce. And a system that has enabled our client Stora Enso to produce a performance toolkit for their shift workers. And on that note, I'd like to hand over to my colleague Veit Hoere, who will take you through this toolkit in more detail. Thank you.
Thank you, Charles. Yeah, and now let's really go to Belgium. Let's go to the Stora Enso paper plant there. And I want to start off with a quote from Chris the Hollander, who's the mill manager there in Langebrugge. And he says, digitalization, automatization, and increased production call for a big effort from our employees. And a smart factory really needs smart workers. So we couldn't agree more with that statement. But in the context of process manufacturing, what does that really mean? What does it really mean to be smart? Before we talk about that, I want to introduce our customer. So Stora Enso is a renewable materials company with headquarters in Finland. They have 5 business divisions, and one of them is really the paper division, which we've been working for in this project here. And what we can see here on that image, that's the PM4 paper machine in Langebrugge. It's been around since 2003 there. And they work in a sustainable way. So they really produce recycled paper from old paper, which they collect or which is collected from households in the region there in Belgium. They also have a biomass power plant on their premises, which is really using waste from their process to generate electricity and heat for the process. But yeah, if we look at the paper industry as a whole, it's really a competitive environment, right? And if you really want to be efficient and effective in that environment, you really need to be a little bit more lean, you need to be more effective with your production, and you need to have smart workers. And for having smart workers, you typically should start at the control room, because there you have exactly those people who are in touch with the process 24/7, 7 days a week, 3 shifts a day, and they can really make an impact with their decisions on the performance of your process. And if we look at the requirements we got from Stora Enso, they really wanted us to focus on the workers in the control room. So they really requested us to deliver a managed process for shift handover, for their lean meetings, and really for leveraging Pi data for all that. And in general, the project was a proof of concept. So we started at the Langerbrugge paper machine PM4, where we did the first implementation. We then rolled the solution out to the mill there in Langerbrugge, and eventually also starting rolling it out to further paper mills in Germany. There's one specialty within that project, which is they have a Microsoft BizTalk middleware in place, and our solution is really part of that architecture as well. So how do you really bring data from the Pi system to the people there at the plant? So we have the process data in the Pi system, let's say downtime, sheet breaks, and so on. And also in Stora Enso, we have this a lean cascade of really information flow and decision making. So for example, we do have the operator report, which basically has all the incidents which happened on the shift of that very operator. Then we have the day report for the foreman, which is really an aggregated view of all the stations in the control room. And then we have the morning meetings, the 8 a.m. meeting, the 9 a.m. meeting. And that really is only for the high priorities and for decision making. And what you now need is really this managed process around that, which can really provide it by Shiftconnector. And to really give you one example, let's say we have a sheet break in the Pi system that gets automatically imported into the operator report, and the operator can now go ahead, click that record, add a reason code, add context to that information, which only he knows because he has been there on night shift. He knows why that loss happened. And maybe then the operator flags that loss for the next morning meeting, for the 9 a.m. meeting, so it's discussed there. And maybe they make a decision so that this issue does not occur over and over again. They will put in an instruction into the system that they have to change a certain machine parameter, let's say lower the run speed or something like that. So this is really the integrated communication we deliver here. I also wanted to give you the technical perspective, really. So on the left-hand side, we do have the Pi system, and it's really interfacing with the BizTalk environment via an OLEDB SQL query interface. We also have an integration with SAP PM in that project. And on the right-hand side, we do have the control room. And there we are mainly talking about two browser-based HTML5 application. One is Shiftconnector with all the communication, documentation, information flow. And the other one is a Power BI dashboard, which really gives you the operational KPIs of the operation, and which is also used for shift handover. Now there is a second way of how we can integrate with the Pi system. It's not implemented there at Stora Enso. It's still worth showing it because we really love event frames in the Pi asset framework. And that's another way of how we can really interface for performance, right? So this is an example from an ISA 88 batch operation. And what we do is really simple. So we look at an event frame, we look at start and end time, we look at the procedural element type. So in that case, it's a unit procedure. And we really take that into the shift log. We compare it with reference values, for example, the best 5-day average for a certain product in a certain reactor. And whenever there is a loss, we trigger that to the operator so that the operator really can account for it, put in reason codes, add context to it. And yeah, with that being explained, let's switch to the actual live demo. So yeah, this is Shiftconnector. Again, it's a browser-based system. So I'm here in Google Chrome. I'm logged in with my Windows Active Directory account. And on the left-hand side here, I really have the organizational structure of my mill. So I'm at paper machine 4. This is the PM operator here. And this is really the log of the PM operator. What we also have here in the organizational structures are the meetings. For example, the day report or the 9 a.m. morning meeting, right? What we also have here, besides the Events tab, and the Events tab is really the operator's report, the log from the operator, is a Task tab. So that shows all the tasks I have to fulfill on my shift and the status. For example, I have to execute a certain checklist here on my shift. And we also have the Instructions tab, and this is typically information which comes from the senior team of the plant, for example, the process engineer. And here we have an instruction that for this product we have to change the machine speed to a certain rating. But what we really want to focus on is the first tab here in the system, which is the Performance tab, actually. And this really shows me the PI data of my paper machine for my current shift. So we have quality material data down here, and we have the time data up here, really. And what the system really does, whenever there is a loss, for example, a sheet break or a downtime, it really creates one of those yellow highlighted items. And what the operator on shift has to know, they just have to go through all those yellow highlighted items and really provide the context information which they have for that loss. So I'm clicking this and it brings me up a form, and there is a range of attributes on that form. This form is a matter of reconfiguration, right? So we can add attributes on that form which come from PI, which come from PI tags or PI event frames. And we can have attributes on that form where we want the operator to add his context information, right? And in that case, I have two mandatory fields. It's really the reason codes, like where did the loss happen, what was the actual reason, and then optional, maybe a cause even, and a description field, right? So I'm adding here a description, let's say something like leaking gasket, and I'm saving that record. And this is basically how I go through all my losses I have in my system on my shift. So I basically walk through all those yellow highlighted items and then close my shift. I want to give you another example. We've been talking about batch operations as well earlier in the presentation. So I want to switch to this other tab here. Exactly. And this is another view. It's not been implemented in Stora Enso, but still worth showing it because this is really a multi-unit batch operation. And also here we have the same system. So we have here unit procedures which come from event frames from PI. The green ones are actually within the reference time. So within, let's say, the best 5-day average, if that is your target. The red ones, they actually exceeded that target. But the yellow ones are the ones which actually held up the process, which now need to be accounted for by the operator, which now need context from the operator. So I'm going to click that unit procedure. What I can now see here is a list of operations, but the system is configured to collect reason codes and context information really on a unit procedure level. So I'm clicking that, and again it brings me up that form which I can use to add context to my loss data here. So let's say this is something with rotating equipment. Let's say pump running slow, need maintenance to check it. And I want to extend the scenario here a little bit. So let's say again I'm on night shift. I want this to be escalated to the next morning meeting. I want that this will be discussed in the next morning meeting. But what I already know is that I want to have maintenance look into this problem, right? So I'm also choosing a functional location here. So that would be the pump, which has that certain issue. And I would also attach a maintenance notification right away to the original loss event. So I'm really creating a chain of records which is linked to the original loss which comes from the PI system. So this is really the maintenance order for SAP PM. SAP PM requires a couple of fields. One is the short name, the other is the priority. I say check pump as a short name and say this is an emergency work order, select the priority, and then I will go ahead and save that record. And now a couple of things happen at the same time. One is I actually accounted for that loss. It's now part of my logs. I also escalated that to the morning meeting, and I also sent a maintenance notification to SAP. So let's say the night shift is ending, and let's switch roles for a moment. Let's assume I'm a process engineer now, and I really want to dive deeper into my data and want to understand what happened over the last week. Then I can exactly also use that view here. I can dive into a certain unit. I can look at a process control chart, and I can now start looking for context, right? So here's a major outlier. And when I'm a process engineer, I can really click that. I can see, oh, most likely the problem was in that operation here. And I can even look at the details and basically see what the operator, let's assume on night shift, really entered for that loss. What were the reason code? What were the description? Feed pump overheated, cooling system unavailable. That totally makes sense for the first operation of the batch. Now, let's switch roles one more time and let's go to the morning meeting, right? So we have the morning meeting here on the left-hand side. And what it really shows is all the escalated items here for decision making. And here's also the pump, which is running slow. And during the morning meeting, I have all information at hand, and I can also see that, oh, there's an SAP maintenance notification already attached to this issue. So that is an overview of what Shiftconnector can do. The next thing we wanted to show, and that's really a screenshot in the Power BI, is a Power BI dashboard. It's really giving you all the operational KPIs in Stora Enso, right? You can basically see what your machine speed is, what your average machine speed is, how you deviate from the machine speed, from the target machine speed, for example, or if you had, or what your stock levels really are at the plant at this moment. And the power of this screen really is using it together with Shiftconnector, where you have the context, right? Why did we have a certain sheet break? Why, for example, did we have to switch to gas in our biomass power plant? And that you can really have in Shiftconnector if you use it alongside. And the beauty of those applications is both are HTML5 browser-based application, so you can really use deep linking as well, right? So you can link from Power BI into Shiftconnector. Yeah, and then to summarize really, for Stora Enso with this implementation really, what we did is we helped them to bring context into shift operations really. They are really able now to see the full picture in their data. Whenever they have a shift handover, whenever they have a morning meeting in the maintenance department, they have the relevant context available. So yeah, please feel free to talk to us if you have a similar use case. And I think we are also ready now to open up for questions.
What's the typical implementation time for?
So what is very important for implementation time is really the status of your PI system, obviously. We always recommend, it's really the best style of architecture if you have your asset framework, if you have your event frames defined. And once you have that in place, it's really simple because we do have a native interface for event frames. Do you have a batch operation or continuous operation?
I'm an integrator, so
Okay, it's a more general question, yeah. But as long as you have, for example, an ISO 88 standard batch operation to have event frames defined according to that standards, it's really simple. It's really click and play.
pricing.
Thank you.
What's the pricing?
So in general, okay, there we go. So we have a pricing model which is basically on a per named user basis. And additionally on a per bottleneck basis, which really comes down to how many control room operators are really using the software for a line or a piece of equipment. And yeah, please feel free to stop by our booth and we will basically talk about the pricing more in detail.
Any further?
V, thank you very much, Charles. Have a good day. And we'll have our next presentation in a few minutes. Thank you.
Thank you for your time.
Thank you so much.